Hello, my name is Ferdinand Bancaro, and the technical challenge that I will discuss for this video is the thesis project that I did with a group during college. The title of our thesis is Map Digitization and Flood Simulation using MATLAB. So MATLAB is a software or a programming tool which is really powerful used by engineers and scientists to analyze data, make models, do algorithms, and etc. Whatever that will make our jobs easier. The limitation with using MATLAB is it is a licensed software because it is really powerful and easy to use. So unfortunately, I don't have that with me. Our university provided the license to work with it or to use it to work on our thesis. So for this video, I can only show you the screenshots of our MATLAB script, our program. So our research aims to create a MATLAB script that digitizes a contour map using image digitization and three-dimensional graphing. So the real purpose or the problem that we were trying to solve here was we wanted to identify which areas in the city are prone to flooding. Because in the Philippines, there is a typhoon season, and every time the typhoon hits different provinces or cities. So we wanted a solution so that we would know which areas that weren't previously affected by the flood which areas would most probably are prone to flooding if they were hit. So our thesis aim start the start the solution because our project can only process simple contour maps. So we cannot our limitation were to process these kinds of maps, and we cannot really process cities yet. So for example, here is an example of what the real terrain of the Philippines yes looks like. So this is an example of a real contour map. So these are the only kinds of data that we can process and digitize. So our objective is to digitize a physical contour map like this one to retain its planar and elevation properties. So the digitized map will be used to simulate a flooding event. So we input parameters that include the rate of rain and the final water level. The final output of the simulation is the water accumulation in the different areas of the three-dimensional map. So another limit is at the boundaries of the map, we assume that there are no outflow and inflow yet. That is a more complicated problem. So we will assume that we are inputting a rate of rain, and then there are walls here. So if the area, for example, if the area, let's assume that the area around this map are all higher than whatever the areas are here at the edges, then our script will work. We will assume we want to find the catch basins of each area. So the problem or the main thing that we needed to do was process each line separately. So MATLAB can only help us process the data if we tell which data we want to process. But for example, in this kind of contour map, um, lines that overlap will pose a problem because it it will interfere with the processing of contour lines. So another limitation of our project is we can only process maps that only contain contour lines, right? Or like in this one. So this is an example of a map that only contains contour lines. It does not contain the other unnecessary markings. And then we were able to isolate each line that are continuous. Our script was able to isolate that if you click on it. So as you can see here, if you run our script and you input a map data to process, the MATLAB will prompt click left with mouse button to acquire, click right with mouse button to end. So right is cancel, left is okay. So for example, we click this one and MATLAB detected that this whole line are connected with, but it is only connected to itself. So it is removed or separate from each other lines in the image. So we were able to do that by processing each line, and then we will make everything else black, and then we actually make this, we reverse it, we actually make this line white because white is the data that has information if it is being processed. So everything becomes black, and then the selected line, contour line, is white, and then we input the z value for that line. And then if you click OK, we process it again so that the already selected lines will retain its red color, and we only select the other contour lines that still need its z values inputted by us. After everything has their elevation, our script can also show a 3D image of the contour plot, which means that now here we have a digitized version of the contour map that retains its elevations and x and y coordinates. So the final thing that we have to do here is create a simulation that shows what the area will look like if there's a heavy rainfall to it. So here are the parameters that we use to show something like this. So the green areas are what land looks like, and then if we put rain, so there will be blue areas to show where water be will stay. Water will stay in these catch basins, and that is how we want to show how our script will be able to solve the flooding problems in the Philippines. So if we increase the rate of rain or the water level, it will show which areas will be under the flood and which areas will be over. So our recommendations for future researchers that want to work on the same problem is boost the capabilities of the program by creating an algorithm which can identify contour lines from topographical maps with other colors and objects. So that is it for our thesis during college. Thank you.